All right, so you had your first limits quiz. I finally got them graded, and they should be heading back to you here this afternoon, assuming I can figure that out. I've already posted comments and scores. I don't know if you can see that or not yet. I really don't understand all of how Google Classroom works, but I think I can hit a send button and get them back to you, and then this video will help you if there were problems you didn't understand. Although you can definitely reach out to me during help session or some other way and let me know if you need help also. Um, I think we only had one person who was in sixth hour who thought they were in third hour this time. So once again, almost everybody knows what period they're in. I guess it's been a month since we've been in school, so maybe you just forgotten. Uh, Now the data is only like 60% of the test because the other 16 points came from free response. But as you can see, um, there was an average of 19, which 19 out of 24 is pretty good. It's around 80%ish. And the median was even higher. So over half the people got 21 or above, which means half the people missed one or less problems. And so, I mean, that's good. Um, it kind of looks weird because there's all these missing values in between, but remember, you could only get 3 points or 0 points per problem. So all the scores were in intervals of 3. A lot of people did get them all right, so that's good. There were no questions that came up as frequently missed uh, like there were last time. So that means that I think everybody, at least half the class, got every problem right, is what that basically means. Let's take a look at number one. The graph below has a bunch of limit statements made. Which ones are true? So is the limit as we approach -5 from the left side, is that equal to 2? Yeah, it looks like the height over here is 2. Um, so I would say that one's good. Is the limit as I approach -5 from the right side equal to +2? And that isn't. It looks like here over here as I come in to as the x's approach, I should give myself a little arrow here, I guess, make it easier to discuss these things. All right. Oops. Probably didn't want to put arrows on both sides. All right. So, which way are we coming in? Are we coming in from this way or this way? That's always the question, right? So as we come in this case, this way, we're approaching -5 from the right. It looks like the height I'm actually approaching is -1, not -5. So that one does not look like it's true. Okay. So the next thing we're going to ask about is approaching -2. What happens as I approach -2? And the first question is -2 from the right, from the left. Sorry, the little minus sign means from the left. So left-hand behavior. Well, that means I'm coming in this way, and it looks like I'm approaching the x-axis. So that's a height of nope, that's 3. Sorry, -2 is here. So it looks like I'm actually approaching. Well, it looks like I'm approaching a height of 6. It looks like 6 up here. So yeah, that one makes sense to me. What about approaching -2 from the other direction, from the right side? That's what option 4 is asking. Well, it looks like I'm actually approaching the same height. It looks like I'm coming in here at the exact same height. So there's a hole there. There's a removable discontinuity, but that doesn't prevent the graph from approaching the same height from both directions. And so I would say that that is true. Okay. So finally, we are going to approach 5, +5. So that's over here, right? As I approach +5 from the left, okay? I don't know if it's hard for you guys to see as you're watching this, but we're looking at that little tiny sign there. Is it a plus or is it a minus? And this one's a minus, so it's from the left. And as I approach from the left, looks like I'm still at a height of 6 up here. So the left limit is 6. So that one doesn't look like it's true. On the other hand, as we approach 5 from the right side, the right limit, it does look like I'm approaching a height of 4. So that one does appear to be true. And so what we end up with is 4 true statements and 2 false statements. And the data shows 74% of you overall got all 4 of those right and didn't choose the wrong ones. Very few people chose the wrong ones, so that I was happy to see that. Um, but it looks like quite a few people might have missed 1 or 2 of the right ones. And so if you missed one, just try to analyze, how which one you missed, and why what you thought was false was actually true. But overall, for one that you had to pick 4 correctly and not pick 2, that's not bad. 74% is actually a decent score. And I'm sure most of you guys got quite a few of these right, if not all of them. So minor adjustments, right? Number 2, it says which must be true if we want the limit as we approach -2 to be 6. I'm gonna grab these arrows and just kind of take them with us because I have a feeling that we could use them again and again. So this time we are approaching an x value of -2. Now we just actually did this one last problem, and what we found is that the left limit um, was 6 and the right limit was 6. And that's good because that has to be true. The left and right limits have to agree for the overall limit to exist. And that's what they're asking. This right here doesn't have a little plus or minus. This is the overall limit, the two-sided limit, we call that, right? And so those two things have to be true. Now, does f of -2 have to be equal to 6? Like, it's not, right? There's a hole there. F of -2 actually looks like it has a value of -2 down here. And the answer is no, that does not have to be true. The limit, remember, doesn't care what's there. It only cares what we're approaching. So if I'm approaching the same height, the limit will exist, even if there's a hole there. What I can't do is approach different heights, like a jump discontinuity, or approach, like there's good jump discontinuity right there, or an infinite discontinuity. So options 1 and 2 and 4 don't have to be true, just options 2 and 3. And very similarly, a ton of you guys picked 3, 97%. A couple of you needed to also pick 2. Now, a lot of people picked 1, but that's saying that we have to have continuity at the point for the limit to exist. But remember, limits don't care if there's a point there. Limits only care that we're approaching the same height from both directions, okay? So pretty good. I mean, not stellar, but these guys are like, yeah, solid effort. Okay, we'll take that, right? Number 3, in this graph, which one of the following statements is false? So this time it's not a multiple select. There's only one false statement, so we have to go find it, right? Let's bring our arrows down and start checking them off. So -3, so we're approaching -3. This is the one I tried to approach back on problem 1, but I should have been approaching -2. And it does look like this time we are approaching the x-axis from both the left and the right, and the limit is equal to a value of 0. So that one seems to be true. What about the limit as we approach 2? So that this time the x values are approaching 2. Well, it looks like we have a horizontal, constant segment up here, and so we're zooming in on a height of 6. Absolutely, that one looks also true. Okay. What about the limit at, and I shrunk this up to fit it in here, so I can't even read that. Is that 5? Yeah. What about the limit at 5? Does it exist or not? Well, here's 5. It looks like the left limit is 6 and the right limit is 4. So because we're approaching different heights, the limit does not exist there, the two-sided limit. So that is actually a true statement. What about the limit as we approach -5? Is that equal to 2? Well, it does seem like the these are a lot of these answers or questions you partially answered on problem one, but the left limit is approaching a height of 2. Unfortunately, the right limit is approaching a height of -1. Remember we talked about that? And so the two one-sided limits do not agree. And so the function cannot have a limit there. And so that, I believe, is the one that is going to be false. Now, why is the last one true? Well, that's just an evaluation problem. What is the function's value? So it's not asking for limits this time. It's just saying what is the value of this function at 5. And at 5 looks like 6, right? The closed circle is at 6, so that's why that one was true. Before we go to number 4, 72% correct, which is okay. But there were certainly a lot of you guys that thought the limit did not exist. Almost 20% of you thought the limit did not exist. Actually, that's option 2. That's good. Yeah, they got flipped. You thought the limit did not exist at 5. And you thought that that was false, but the two limits don't agree, and so the limit does not exist. That's what makes that a true statement. So about 20% of you missed that one. That's a lot. So I hope that this discussion helps you clarify that a little bit. If not, let me know. All right, now let's jump to number 4. A two-sided limit will exist at, okay, will it exist at a hole? So let's just draw a couple of sketches here. Here's a hole where we have a function that just has that removable discontinuity. Will it exist at the vertex of a parabola? You know, so that would be this this value right here. Will it exist at this vertex? Will the limit exist here? And then finally, will the limit exist at a vertical asymptote, So if we had a vertical asymptote somewhere, say over here, and I had my function um, coming in from both directions and approaching either positive or negative infinity, we'll say it goes to negative infinity this way, and we'll say it comes in and it kind of goes towards positive infinity that way. Will the limit exist there? Well, let's tackle these. Let's tackle these one at a time. I might have to stop and shut my dog up first. Let's see if he stops. Yeah, she's okay. All right. So will a two-sided limit or an overall limit exist at a hole? And the answer is yes, because the heights, the left height and the right height that we're approaching, right, the left limit and the right limit are approaching the same value, the same y value. So the answer on that is yes, that's good. Will it exist at the vertex of a parabola? Well, parabolas are continuous, so right off the bat, that's a good sign. But certainly, as we come in from one side and if we come in from the other side, we are definitely approaching the same height, the height of the vertex itself. So yes, it will exist at that point. And then finally, will it exist at the vertical asymptote? Well, this time I think we're out of luck because infinity is not a real number, and so we're not approaching the same height. Even if they were both going to positive infinity, that infinity is not a real number. So it does not mean that they will ever meet up at a location. Even if the location's not there, like with the hole, it would still not work. So of these three cases, the one that does not have a two-sided limit is the um, infinite discontinuity. And so what we're going to do is we're going to say the other two work, and that means the answer was this one right here, a hole in a parabola vertex. Okay, so if you missed that one, hopefully this explanation helps you out. How many people did miss that one? Oh, about a quarter of you. about a quarter of you. So think about why. I mean, you know, if you said three of you said it exists at a whole, and that's absolutely true, and six of you said it exists at a parabola's vertex, and that's absolutely true. And so you guys just needed to put the other ones together. Um, Nobody said it existed at a vertical asymptote except for these six people who said a hole and a vertical asymptote. But a vertical asymptote, we're not approaching the same height. So not bad on this one, but that's the math behind it. So on this guy right here, we're going to have to do some factoring, right? We want to know when a two-sided limit exists. And so we're going to take the limit as x goes to c of x minus 3 over x minus 3 times x plus 3, right? The bottom is difference of squares. So it looks like the canceling factor, which creates a hole, is at x equals 3. And the vertical asymptote, um, the infinite discontinuity, is at negative 3. Well, we know that limits cannot exist at infinite discontinuities. And so at negative 3, there will not be a two-sided limit. However, at holes, as we just saw in the last problem, we're coming into the same height, regardless of whether there's a point there or not. So definitely 3 is going to work. Now, what we learned in Unit 1 about rational functions is they are continuous and defined everywhere except at the zeros in the denominator. And the only zeros in the denominator were 3 and negative 3. And so these other two numbers, 0 and 9, are absolutely going to work. I mean, those are going to be fine. If I plugged a 9 in there, I would get 6 over 72. Okay, so that's 1/12. Okay, so it would be continuous approaching a height of 1/12 from both sides. If I plug a 0 in there, I get negative 3 over negative 9, which is 1/3. So at the y-axis, when x equals 0, we will have a y-intercept of 1/3, but we're approaching the same height from both sides. So really the only bad one was negative 3. And this might have been the worst one. You know, only 62% of people got it right. There weren't too many people that picked negative 3. 11 people did, and so obviously that's going to make you miss this problem. But a lot of people picked 0, 3, and 9, which is awesome. It's just probably not enough people picked all three of them. So think about the one maybe you didn't pick and think about why it was okay to say that it's going to have a two-sided limit at that value. And if it makes sense, then you learned something from this problem. And if it didn't, you should reach out to me and let me know. Number 6, which of the following functions will not have a two-sided limit for all real numbers? Well, this really is going to test you back, in Unit 1, how much do you remember your parent functions? An odd root function, right? An odd radical has a domain of all reals. And if it's always going to be defined and it's always continuous, which this function is, right? It kind of looks like that. Then yes, it will have a two-sided limit. Now tangent has infinitely many vertical asymptotes, doesn't it? It kind of looks like this, and then like this, and then like this. Well, it's going to have infinitely many infinite discontinuities, and every time it has one of those infinite discontinuities, it will not have a two-sided limit. So I believe option 2 is probably going to be the one that doesn't work. But we could go through and just finish off and verify the rest of them do. For example, problem or option 3, x squared. Well, it's a parabola, so it's continuous everywhere. So yeah, it's good. What about a line? Yep, continuous everywhere. What about a horizontal line at 3? Yes, continuous everywhere. All of the other ones all are continuous throughout, and so we'll have two-sided limits everywhere. It's really only 2 which had the issues with all those infinite discontinuities. All right, so now we can start getting into limits. And by the way, this was, I think, your best overall question. 86% of you guys nailed that one, so good job. Number 7, um, you know, this function is defined everywhere, so there's really nothing to worry about. So I think we just need to jump in and evaluate this one using substitution. So we're going to take the cube root of 60 plus 4, the cube root of 64, so 4 is the answer for this problem. But you didn't have to show work on this, obviously, but notice I immediately substituted, so the limit went away. I didn't have to keep writing the limit, okay? I don't know what work you showed, but it looks like only one person might have missed this one. 99% of you got it right. So, whoa, nice. I guess I was wrong about the previous problem, though. This is the one that you got the most often correct. Now, this one's going to require a little algebra. So we are going to need to um, distribute the x minus 7 squared. Notice I have not plugged anything in yet. I need that limit notation, right? We can then get rid of those 49s and factor out an x, right? Still haven't evaluated, still need the limit. And then I can cancel those x's. So now all I have left is x minus 14. Anytime you have a binomial or more terms, you really should use parentheses to show you're taking the limit of the entire thing, not just the first piece, okay? Now it's just a substitution problem. I can now plug that 0 in, right? And I don't need to write the limit anymore. And of course, 0 minus 14 is negative 14. And how many of you guys got that right? Oh, 90%. So really good, solid number. Well, it looks like there may have been some algebra mistakes with some of these other answers. If you said it was undefined, you probably did not do the algebra. You probably just immediately substituted the 0 in and got 0 over 0, which is undefined, but that doesn't mean the limit doesn't exist. There's a hole there, and so the limit does exist. You just have to do the algebra to prove it. So good job. Matt's happy with you too. All right, so that's the part that that was easy for me to grade. The rest of it slowed me way down. I was very happy that everybody got to this point right here and marked okay. You guys were all like, oh, okay, I have to keep going on to the next part. Sure, I can do that. Look at that, 100% of you. So, woo! Of course, it wasn't worth any points, so we shouldn't celebrate too much. As far as these problems go, I made comments individually, so hopefully you can listen to those comments and understand, and let me know if you don't understand the mistakes. I'm just going to go through the work, and we'll be done with this. For number 9, at first you're like, wow, the top doesn't factor. How am I going to do this? But then you realize there's only one number where this is not a continuous function, and that's at 1. If you look at the bottom, only a 1 gives you a 0 in the bottom. And this, we're not taking the limit as we approach 1. So just plug your negative 5 in, right? And then simplify it. And it looks like we get 53 over 12. And that's your answer. And a ton of you guys got that perfect. A couple of you guys kept writing the limit notation along the way, but once you make your substitution, you've now taken the limit. Okay, we're not evaluating the limit anymore. We've now taken the limit, and so the limit notation is no longer necessary. Okay, now some of you guys made the opposite mistake and didn't write the limit notation at all or for long enough. These are very important notational mistakes to understand. If you don't know when to write the limit and when not to write the limit, then what that means is you really don't understand the concept of limits. There's different algebraic ways of doing this one. Some of you guys got common denominators, but most of you just multiplied both the top and the bottom by this. Now, some of you guys just multiplied the top by it and assume that that also counted the bottom, but it doesn't. So you got to show the work correctly. Now on the top, we're going to get some cancellations, and we'll just get 5 times 3 is 15, minus 3 times x plus 5, which can then be distributed, right? Now the 15s cancel, and this is going to finally allow me to get rid of these x's, and this x right here is the original x which prevented me from using substitution in the beginning, and so I can finally get rid of that, and that's really the key part of this problem, because after that I can plug my 0 in and I get negative 3 over 5 times 5, which is 25. So negative 3/25ths, and a ton of you guys got this one correct. Some of you guys made some little minor mistakes. Number 11 is just a factoring problem. If I plug 4 in right away, I get 0 over 0, but if I factor the top and the bottom and cancel those x minus 4s, I can now very easily plug the 4 in. And this problem was, along with number 9, probably the most often correct. Finally, number 12, this is the one that people struggle with the most, and it really wasn't as much as the answer goes, because a lot of you guys got the right answer, but your work didn't make sense. The first thing I want to do is split the fraction. And when I split the fraction, I can do the fraction first and then split the limit, or I can split the limit with the fraction all at once. But what a ton of you guys didn't do is you didn't split the limit. And so when you turned sine of 4x, this is what your work would have looked like if you had done it the way I'm describing it. Okay, it would have been the limit as x goes to infinity of 8x over 4x minus sine 4x over 4x. And so this, you eventually, I think, turned it into the limit of 2, which turns into a 2. But this, you just turned it into a 1. And I think in your mind, you're thinking, well, the limit of this is 1, but you're not showing that you're taking the limit of this. And sine of 4x over 4x actually never has a value of 1. We get really, really close to 1. It kind of looks like this, right? But never even equals 1. And so when you do that, it's a big substitution that doesn't make any sense. You have to split the limit. That's a really important step. Now the 8x over 4x turns into a 2, and then we can, the limit of a constant is itself. The limit of sine of 4x over 4x is as we approach 0, and only if as we approach 0 is 1, and then you subtract. So a lot of people got the right value on this, but weren't showing the right work. So hopefully that was a good learning experience. A lot of you guys just factored the x minus 9. I didn't really expect many people to factor the x is the difference of squares, but a lot of you guys did, which is fine. I just use conjugates. Whenever you see roots in these types of problems, conjugates is always a good idea. So I multiply by the conjugates. Now, I am not going to distribute these because that would make a big mess. And some of you guys did that and then got stuck, and some of you guys did it but then had to work your way back, and so that was not very efficient. On the bottom, I'm going to get difference of squares, x minus 9, but see, now I can just cancel these x minus 9s. And then once you get to this point, we don't have the root x minus 3 in the bottom anymore. I'm happy to plug that 9 in. So a ton of you guys did get the right answer on this one and picked up some bonus points. Some of you guys, your work didn't quite make sense, like you didn't write the limit enough, or you wrote the limit for too long, or your algebra was missing steps, or maybe was a little not efficient enough. But a lot of people did pick up some bonus points on this. So that's good. All right. Hope this wasn't too boring for you. Apparently that bonus was kind of boring for you because a ton of you guys got that one right. So I'll try to come up with a better bonus in the future. And I think that's it. So hopefully this helps you in case you had any questions on the quiz you just are getting back. But it's the end of our program. Au revoir.